Okay, now we're gonna do modeling with formulas, which sounds a little like more difficult than it is. So let's see. We don't need to. Oh wait, do we need to do this one? Yeah, we do. Goodness, what was I thinking? Okay, so the relationship between how high you are and how far you could see is given by the formula d2 square root 3.2h, where h is your height in meters above the ground and d is your distance in kilometers to the horizon. How far can you see the 360 from this restaurant? Okay, so how far is talking about distance, right? And we know our height. So this is our formula. And this is saying how far, but we have the height. This is our height. So we just plug it in. 2 equals 2. D equals 2 times 3.2 times 351. And that equals 67 kilometers. There we go. Now, from the sky pod, the horizon is 75.64 kilometers away. How high is the sky pod? So this one we're doing the opposite. We are solving. So we have the distance, so 75.64 equals 2 times 3.2h. We want to find h. So first, let's do our opposite operation and divide. And then we get 37.82 equals square root 3.2h. And then we can square the side to get rid of the square root. And then that equals 3.2h. Then that's 1430.3524. You have to use a calculator for that. Divide by 3.2. And you'll get h, which is 447 meters, roughly. Could be 4, it's a little bit more precise than that, but that's good enough. And which was easier to solve? Well, clearly A, because we had A, because it was D equals. No, we didn't have to find the variable. We didn't have to solve for variable. There we go. Okay, so learning goals. In this lesson, you will learn how to rearrange formulas to isolate for different variables. Okay, when working with the formula, the known variables can be substituted first, and then this equation can be solved for their variable. We want to use this one. So the formula can be rearranged to isolate the required variable and then known as the known values can be substituted for the formula. So this is pretty easy. We just want to isolate for A. So we could just do minus A, D minus A plus, oh no, we could just go like this. Minus B, D minus B equals A. Isolate for R, so we can just divide by 2 pi, and then we'll get that divided by that. So C divided by 2 pi equals R. Isolate for X, okay, we could just do square root Y equals X, just to get rid of that. There you go. Isolate for X, so we could do Y minus B equals MX divided by M. Y minus B divided by M equals X. Isolate for W, same thing, times Q, VQ equals W. Isolate for V, so we want to do times by 2, K times 2 equals M V squared. Then we can go and divide by M, and then we could say that that is 2K divided by M equals V squared. Just square it to get rid of that thingamajigger. And 2K equals 2 times K equals K times 2. So it's same thing. Isolate for F. Okay, so now let's do that. First we can times by 9. C times 9. Or we could do 9C equals 5F minus 32. And then we can go 9C equals 5F minus, what is that? What is 5 times 32? 5 times 32, 160. 9C equals, plus 160 equals 5F. 9C divided by 5 equals F. There we go. And then let's go to the next one, application. Okay, so the area of a square is related to the length L of the formula by A equals L squared. Find the length to the nearest tenth of a centimeter of the side of the square with an area of that. Okay, so we know that area equals length squared. And we know that the side of the square with the area is 32, so we know the length. So we can go that equals that, and then we could say that length equals square root of area, and then we could just put our, like that. Pretty easy and snazzy because of this formula it gives us.